Hello and welcome to part 5 of the VisPy Real-Time Data Visualization tutorial series. In the last video, we used multiple threads to separate our data generation from our GUI event loop, keeping the user experience nice and interactive and flowy. In this video, we're going to change our code to look a little bit like it did in part 3 with timers and no for loops in our data generation, but we're going to keep the idea of multiple threads so that we can still keep everything separate. Let's look at some diagrams to see what this looks like. So this is what our diagram looked like for part 3. We had an external timer object and it was asking a data source to update every interval seconds. That data generation would run a single iteration, generating new NumPy arrays and emitting a signal with that new data for the visualization to get updated. In part 4, we changed our complex data generation method to run a for loop and continuously run, but we put that data generation in a separate thread so that it wasn't interrupting or getting in the way of our GUI event loop handling mouse and keyboard events and drawing events. We talked about how this looks in the event loop, where on the right-hand side of this diagram, we have the GUI event loop, the key presses, the mouse presses, the drawing events, and that thread can continuously go through those events and handle them as quickly as it can. We then on the left here have our background thread where our data generation is taking up the entire event loop of that background thread, just running a for loop continuously. We used Qt signals to communicate between the two threads. If you remember from the last video, there was a lot of complicated direct connection and this data generation needs to stop and this thing needs to quit and this thing is closing, and it got a little complicated. And most of that was due to this data generation essentially event taking up the entire event loop of that background thread. What we're going to try to do in this video is split that data generation into individual iterations. By doing that, we have these little gaps between each iteration. This allows Qt to slip new events or new tasks in between the data generation steps. If you remember, there was a special method for telling the data generation to stop, and that had to do with that weird direct data connection so that it could run in some thread and that the background thread could receive that signal in some way or receive that Boolean flag. By doing things this way, where we have data generation doing one iteration at a time, we can allow that stop generation to run in the background thread in between data generation steps. So once we've run this data generation, when we're about to go to the next iteration, the stop generation event that was triggered by the main GUI thread will run, setting that Boolean flag, and then our next data generation will check that flag just like it did in the last video, and it will be able to end quickly. It will be able to say, I'm finished, I'm not going to generate data anymore, and be done. And then the event loop for that background thread will be complete. What our diagram ends up looking like from a high level is very similar to the timer-based diagram, except this time we're putting a timer, a specific version of a timer called a one-shot timer, inside our data source, essentially. So our complex data generation will run for one iteration. It will tell the timer to trigger the generation again. That will add that data generation task to the background thread event loop. And every time that data generation runs, it will also emit the new data to the GUI side of things. So let's see what this looks like in code. So we're looking here at the run data creation method that we had in part 4. This has the for loop, and it's running for some number of iterations, and it's looking for this should end Boolean so that it can break out of this loop. As I mentioned when we were looking at the diagrams, we're going to still use this Boolean flag, but we're not going to do a for loop anymore. What I can actually do is borrow the code from the part 3 video, where we had our data generation based on a timer. I have a copy of that old script here. I'm just going to copy and paste it below our current method. And then I will comment this for loop based one so that we can compare it once we've made our updates. So looking at this again, we see that we're running this method every iteration. We're checking how many times it's been run so far, and if it's been run some number of iterations, we're going to return. This might not be how your real world case is set up, just because you're probably listening to something else that has its own method of telling you how it's done, or you might just want this to run continuously until the user closes the GUI. One thing we do need to do is recreate this self_count instance variable now that we need to keep track of what iteration we're doing. The other thing we're going to add here is our should end Boolean flag that we used in our threading based example from the last video. We're going to print out here that the data source is finishing, just to give us some information or some indication that things are ending. And then we're going to use that same finish signal that we used before in the threading example here. And so this will let the thread handle, as well as the main GUI thread, if we choose to, tell them that the data source is done. We'll use a 1-second timer for now, just to see things as they progress. The data generation is going to be the same: image data, line data, increment the count, make a dictionary of the new data, and then emit it. And then the last fancy thing we're going to do is we're going to use a special class method of the QTimer class that Qt provides us. And we're going to say, with no delay, add the run data creation method, this method itself, to the background threads event queue, the event loop. So we're already running in the background thread. So when we use this method, it's adding it to the background thread event loop, not the main GUI event loop. I think because we're using single shot, we can also remove this timer event. And so this will allow us to run our data generation one iteration at a time, leaving gaps in between in between the iterations for new tasks or new events to be added to the event loop and to be handled. So that should be it for what needs to change in the data source. We're going to delete this old commented out code because we shouldn't need it anymore. But you can see, looking at it, that it's very similar to what we're doing now, just not in a for loop. I'll also point out that we haven't added any new signals. We still have the new data signal, the finish signal. Those were there when we were doing the threading, and we're still using them here. The stop data method is also still the same. It's just a simple method setting a Boolean flag so that we know at the top of our data generation whether or not the main GUI thread or the main window has told us to stop. All right, let's update our signal connections. First, the thread creation, the data source creation, moving the data source to the data thread, that's all the same. A lot of our signals are the same. When we get new data from our data source, we're going to pass it to our canvas wrapper update data method. When the thread is started, that's when we want our data generation of our data source to be started. When the data source is finished and it doesn't want to generate any more data, we're telling our thread to quit and clean up any resources. It shouldn't be needed anymore. From the experimenting I've done, this seems to still need to be a direct connection. Otherwise, you run into a race condition where the thread tries to close and completely close itself before the data source has had time to completely return and stop running. The next thing is the window closing signal that we created in the last video. That's still going to be connected to the data source stop data, but this one doesn't have to be a direct connection anymore, because now that there's those gaps between the data generation iterations, we can slip in this method call and run stop data inside the background thread. The data thread finishing being connected to this fancy delete later method, that's the same. The thread and the window are shown and started the same way. And we are still using data thread wait to wait for anything on the event loop to be finished and cleaned up before we finally close the application. So let's try running this. We have a 1 second delay right now. Okay, so we can see updating data. We see the random image updating. We see new line plots, new line plot points. I'm able to quickly, with no interruption, change the colors of these visualizations. I'm still able to fluidly pan and zoom while the data is updating, so that all works fine. Let's close it and see if the messages indicate a clean close, and they do. We see data source was quitting, it's finishing, it sent that signal. The thread was waiting for things to close down nicely, and they did. Let's try running the data generation a little faster. So we'll comment out the 1 second sleep. We'll run this as fast as it can go. All right, so that's how fast that went. Still able to change things even though the background thread has closed, because none of the tools that we're using, the pan zoom, the color changing, none of those are actually interacting with the background thread. If they did, if your application required some communication between the user and how that data generation is done, you might want to keep that thread around so that you can access some of those methods and do some of those things in the background if they're needed. Looking back at our slides to summarize what we've done, we went from having a timer outside our data source, triggering individual things, individual data generation in the main thread, to running a for loop continuously in a background thread that required kind of hacky interruption to be able to stop it, to be able to interact with anything else in the application, to finally, in this last example, adding a one-shot timer to our data generation to essentially keep triggering itself, but leaving that gap in between iterations to allow communication with the main GUI thread. The other key point of these examples is that none of the visualization stuff, none of the VisPy visuals really cared about any of this data generation. They were able to use their existing interfaces with set data and the existing .native property of the scene canvas to be added to this Qt GUI and allow the GUI and the user to interact and update the properties and the data of those visuals. Well, that is it for part 5. This is the last video in this planned series of videos. I may do more videos with optimizations to this, or maybe showing different visuals. If you have any suggestions, please leave them in the comments below. As always, if you find any issues with these examples, if you have any new ideas, VisPy GitHub issues are also a good way to get in contact. There's also a VisPy mailing list. All of that is linked in the description below and in the VisPy documentation. Thank you for following the series, and I hope to see you in whatever video I make next. Thanks.